So I decided to do a quick little video on L'Hopital's rule. That is, let's see, L'Hopital''S. L'Hopital is about as close as I can get to pronouncing it correctly. So L'Hopital's rule is a clever little tool that you can use in calculus for solving limits. Now I'm sure its usefulness is probably far beyond anything that I understand, given the fact that I am not a mathematician. But as far as solving for limits, and if you're taking a test or the AP exam and you come across a limit problem, you may want to use L'Hopital's rule. So now the first thing I want to say is be careful when you use L'Hopital's rule, because it has limitations on when it can be used. The basic idea here is this, let's say that you have a limit. Let's say it's the limit as x approaches 5 of, and I'll do something that you're familiar with, of x squared minus 25 over x minus 5. It's a pretty simple one. We've done a bunch of these where you got the difference of squares up top, and eventually you have to kind of you got to factor the top and then cancel the x minus 5, and then what you have left over typically is the limit as x approaches 5 of x plus 5, and the answer is 10 when you substitute the 5 in, right? Okay, so you've done a bunch of these, so we know that the answer is 10, but we also know that before we do the algebraic manipulation, we know that this is an indeterminate form. If we do the first thing we're supposed to do, plug the 5 in. 5 squared is 25, minus 25 is 0. 5 minus 5 is 0. So we get 0 over 0. And here is the important part. This is an indeterminate form. L'Hopital's rule can only be used if substituting gives you an indeterminate form. If substituting gives you an actual answer, then L'Hopital's rule cannot be used. It will not apply. And if you try to apply it, it'll mess you up and you'll get the wrong answer. Okay? But here's what L'Hopital's rule says. And you're going to laugh at this. You're going to crack up at how simple this is. L'Hopital's rule says that if you have a limit that when you substitute gives you an indeterminate form, that you can solve this limit simply by taking the derivative of the top, just the derivative of the top, not the quotient rule. You just do the derivative of the top over the derivative of the bottom, and then substitute for the limit. And here's what I mean. We're going to bring over the limit. This is going to be equal to the limit as x approaches 5 of the derivative of the top is 2x, and then this becomes 0, so just 2x, over the derivative of the bottom, the derivative of x is just 1. So the answer to this is going to be the same thing as the answer to this. And now when we plug 5 in, we get 2 times 5 is 10, over 1 is 10. There you go. Wasn't that awesome? Didn't need any algebra really. All we needed was calculus. We just had to take the derivatives. Isn't that beautiful? Okay? And it works in just about or pretty much anything. Now before I do a couple more examples, I want to show you how it could get messed up. Now watch this. What if this was x squared minus 25 over x plus 5? This is not going to result in an indeterminate form. 5 squared minus 25 is 0. 5 plus 5 is 10, and this equals 0. This has an answer. The correct answer to this is 0. You do not need L'Hopital's rule. But let's just say that you were, really zealous and you saw a limit and you said, oh, I know how to handle limits. I use L'Hopital's rule. And you applied L'Hopital's rule here, you again would get, the limit as x approaches 5 of 2x over 1, and you would now get 10, which is incorrect. The correct answer to this limit is 0, and you're getting 10. So it's wrong. You applied L'Hopital's rule in a situation where you do not have an indeterminate form. So you have to be very careful that what you are dealing with is an indeterminate form. Okay, similarly, let's say that we had, putting this back to x minus 5, let's say the numerator was x squared plus 25. If we plug 5 in, we get 5 squared is 25 plus 25 is 50 over 5 minus 5 is 0. Now, this is not an indeterminate form. This indicates that there is a vertical asymptote at x equals 5. That is a correct, well, this gives us an answer, and it indicates that the limit does not exist. Okay? There is no limit. It is not an indeterminate form. There is no limit. But if you were to apply L'Hopital's rule in this particular situation, once again, you would get 2x over 1, and that would give you 10, which again would be wrong. So it is very important when applying L'Hopital's rule that you ensure that it is an indeterminate form before you apply L'Hopital's rule. Okay? So let's look at something else, some other example. Let's say that we have the limit as x approaches pi over 2, okay, of cosine of x over 1 minus sine of x. So now, if we were to plug pi in for cosine, we would, or in for x here, we would get cosine of pi over 2, which is 0. And then we would have, and then sine of pi over 2, well, that's 1, and 1 minus 1 is 0. And so we have an indeterminate form. And don't you think maybe this would be a huge pain in the butt to try and solve analytically? We'd figure it out, but it would take some time algebraically. But with L'Hopital's rule, wow, this is going to be awesome. We're going to go the limit as x approaches pi over 2. And now we're just going to do the derivative of the top, which is negative sine, over the derivative of the bottom. Well, the derivative of 1 is 0. Minus sine of x, well, the derivative of negative sine of x is negative cosine of x, okay? And so now when we plug pi over 2, negative sine of pi over 2 is negative 1 over negative cosine of pi over 2. Well, that's 0. Look at that. We've got a vertical asymptote there. And we, we didn't see that when we had the indeterminate form, okay? Similarly, we could have, let's say that we did it the other way around. Let's say that we had the cosine on the bottom and we had the 1 minus sine on the top. Okay? Now, it's going to be, again, 0 over 0. But now when we do the L'Hopital's rule, pi over 2, derivative of the top, now, just like the derivative we just did, is going to be negative cosine of x over negative sine of x, and now we wind up with pi over 2, 0 over 1, which is a value answer, which is 0. Okay? So L'Hopital's rule, very, very useful, very clever. By the way, it also works on limits at infinity. Isn't that awesome? Okay? Let's say that we have I don't know, let's give it 2x to the third power minus 9x over, let's say 3x to the third power plus 5. Okay? And you're looking at this and you say, oh, I know how to do that. It's a limit at infinity. My power in the numerator, my power in the denominator, excuse me, they are the same. So I know that the answer to this is 2/3. Well, let's say you couldn't remember your rule on how to solve limits at infinity, and you couldn't remember which type this was. Well, when we put infinity here, here, and here, when we substitute, we get an indeterminate form. We can't really plug infinity in. Because it's an indeterminate form, we can use L'Hopital's rule. When we do the derivative of the top, we will get 6x squared minus 9 over 9x squared. You look at this and say, well, that didn't help me at all, because now when I plug infinity in, it didn't make anything better. I still get an indeterminate form. Well, if you get an indeterminate form after doing applying L'Hopital's rule, you just apply L'Hopital's rule again. So now we're moving on to, let me make this an arrow. It's not really, make this an arrow. The derivative here is going to be 12x over 18x. Well, that didn't help me much, except for the fact that I just got rid of the minus 9. Now I can cancel an x, and look what my answer is. 12 over 18, which is actually 2/3. So you can see how L'Hopital's rule can be used to simply deal with limits at infinity in a very clever way. And let's say you're wondering, well, hey, that's pretty awesome. Why don't we use it for, what if this was just x squared? Okay, well, if we apply L'Hopital's rule, this becomes 4x minus 9 over 9x squared. And then if we apply it again, we would get 4 over 18x. And I hope at this point you remember that this is just a transformation. It's just a form of 1 over x, which has asymptotes at 0. And so this is going to equal 0. Okay? So there you go. L'Hopital's rule, very clever, very useful. Look in Chapter 8. It's in Chapter 8. I believe it starts on page 444. So if you want to look it up and remember it or try a few examples, this can really help you with a final exam in the fall. It can also help you out with the AP exam. You really should know L'Hopital's rule. And that's all I got for you. Okay? So enjoy.